Good evening, everyone. Welcome to today's presentation on computer science with a deep dive into the fascinating world of computer networks. My name is Ashikur Rahman, and we will be following the excellent material prepared by Ashikur Rahman. Let's begin. First of all, learning objects. Before we jump into the details, let's outline what we aim to achieve in the first part of this session. By the end of this section, you should be able to define what a computer network is, discuss the advantages and disadvantages of using networks, and describe the main types of computer networks. What is a network? So, what exactly is a computer network? At its simplest, a computer network is two or more computing devices connected together to share resource and communicate. A key thing to remember is that the thing computer here is board. It doesn't just mean a desktop PC. It includes laptops, tablets, smartphones, smart TVs, and even gaming consoles. Any single device that isn't connected to others is known as a standalone computer. While it can function on its own, its potential is limited without connection. Advantage of networking. Why do we go through the trouble of connecting all these devices? Because networks offer significant advantage. Centralized data and file share. File can be stored on a central server. This means anyone on the network with the right permissions can access them from any connected device. It eliminates the need of emailing files or using USB drives. Resource sharing. Trace the most classic example is a shared printer. An entire office can use one or two high quality printers instead of having a cheap printer at every desk. This applies to scanners, copiers, and even internet connections. Shared internet connection. A single internet connection brought into a building by a fiber or cable line can be shared with dozens of devices simultaneously using a router. Centralized management for business and schools. This is crucial. System administrators can deploy software updates, create user accounts, and run backups from one central location, ensuring consistency and security across all devices on the network. Disadvantage of networks. However, networks are not without their challenges. It's important to understand the disadvantages. There are three types of disadvantages like availability, performance, and management. Availability issues. Networks introduce a single point of failure. If a central server or a key network cable fails, many users may lose access to files, applications, or the internet. A stand-alone computer keeps working. Performance issues. As more devices join a network and demand resources, the network can become congested, leading to slower speeds for everyone. Network performance can also be affected by hardware limitations and distance. Management and security. Managing a network, especially a large one, requires specialist knowledge and skills. It also increases security risk if network provides more points of entry for malicious actors, requiring firewalls, antivirus software, and constant to protect data. Type of networks. Networks are categorized based on the geographical area. They cover the three main types we will discuss are PAN, LAN, and WAN. First of all, personal area network. Let's start small. A PAN or personal area network is used within a very small area, typically within a person immediate space, often just a few meters. The most common technology used here is Bluetooth. Examples include the connection between your smartphone and your wireless headphones, your smartwatch with your phone, a wireless keyboard talking to your computer, or the device connected to your car's entertainment system. It's a network for your personal device. Local area network, LAN. We have the LAN or local area network. This covers a small geographical area, like a single building, a home, an office, or a school. LANs can be wired, which are very reliable, or wireless. Examples, your home Wi-Fi. The network connecting all the computers in a school's IT lab or the system in a small business office. Wide area network, WAN. The largest type of network is the WAN or wide area network. This spans a large geographical area, a city, a country, or even the entire global. The most example of a WAN is the internet itself. It is a network of networks connected by unrestricted cables, satellites, and massive fiber optic lines. The other examples, branches of a major bank across a country or a mobile carrier's network that provides service nationwide. Let's do a quick check of your understanding. Here we have a drag and drop activity. Can we sort these examples into the correct category? LAN, PAN, or WAN? 10. Smartwatch, headphones in car systems. LAN, home network, office network, school network. WAN, the internet, mobile network, bank network. The next topic is TCP and IP model. Now let's move on to the second major topic, how devices actually communicate over these networks. This is governed by the TCP and IP model. Learning objects. Our learning objects for this section are to describe the four-layer TCP and IP model, describe the function of each layer, and understand the key protocols that operate at each layer. Introduction to TCP and IP model. Communication doesn't happen randomly. It follows strict rules called protocols. The Internet uses a suite of protocols organized into a stack of layers known as the TCP and IP model. This model has four distinct layers, each with a specific job. Think of it like sending a letter. One layer writes the content, another puts it in a envelope with an address, another device, the postal route, and another physically drives it. First layers, application layer. The top layer is the application layer. This is where network applications operate, like your web browser or email client. This layer is responsible for presenting the data to the users and for using the correct protocol to communicate with remote server. It adds header information that acts like a label for the data. The key protocols here include HTTP and HTTPS. For accessing website is the secure version. SMTP or IMAP for sending and receiving mails. FTP for transferring files. The next, data from the application layer is passed down to the transport layer. Its main job is to break down the data into manageable called packets. It gives each packet a number so the receiving device can put them all back together in the right order. It also adds source and destination port numbers to identify which application on the device the data is for. There are two main protocols here, TCP and UDP. TCP, Transmission Control Protocol. This is reliable. It establishes a connection and checks that all packets arrive. If any are missing, it requests them again used for web pages, emails, and files. UDP, User Datagram Protocol. This is faster but unreliable. It sends packets without checking if they all arrive. This is better for live streaming or online gaming, where speed is more critical than perfect accuracy. The next layer is internet layer. The internet layer is the postmaster. It takes the packets from the transport layer and routes them across the network to the correct destination. Every device on a network has a unique IP address. This layer adds the source and destination IP address to the packet header, essentially putting the destination address on the involve. It then determines the best possible path through the network to get the packet to its destination. Link layer. Finally, we have the link layer. This is the physical foundation of the network. It encompasses and the protocols that control the hardware devices and the transmission of the raw data bits over the physical medium. It converts the packets into signals that can be transmitted. Common protocols included Ethernet for wired LAN connections, Wi-Fi for wireless LAN connection, 4G and 5G and satellite for mobile and long distance wireless links. Let's pause and summarize the TCP and IP model. Can you briefly describe the function of each layer? That's great. Application layer operates the application's communication using protocols like HTTP. Transport breaks data into packets, manages sequencing, and uses TCP or UDP. Internet routes packets across network using IP addresses. Link handles the physical hardware and transmission of data over cables or wireless signals. Now we move to the next topic, network topology. Now let's talk about the physical and the logical layout of networks, known as network topology. Learning objects. For this section, you should be able to describe common LAN topology, bus and star. Describe the difference between them and select the most appropriate topology for a given scenario. What is a topology? We already know a network is connected computers. The topology defines how they are connected and organized. The two main types for LANs are bus and star. Bus topology. In a bus topology, all devices are connected to a single central cable called the backbone or bus. Data is sent out along this cable, and every device sees it. but only the device it addresses to accepts it. It's simple, cheap, and easy to set up for a small network, but it has a major weakness. If the main cable fails, the entire network goes down. It also becomes very slow and unreliable as more devices are added due to data sent. The next is star topology. The star topology is the most common layout today. Here is device has its own dedicated cable to a center called a switch. The switch is intelligent. It receives data and only sends it to the intended device. This is far more efficient and reliable. If one cable fails, only then one device is affected. The rest of the network remains online. The downside is that it requires more cabling and the central switch is a critical potential device. Ring topology. Another less common topology is the ring topology. Here devices are connected in a closed loop where each device is connected to two others. Data travels in one direction around the ring. It can be efficient as every device has equal access. However, its major flaw is that a single break in the cable or failure of one device can break the loop and take down the entire network. This is why it's not widely used anymore. Now let's sort the characteristics which belong to bus and which to star. Okay, that's great. Bus topology uses a backbone cable, cheap and easy to set up, not reliable and large scale. Star topology uses a centralized switch, use more expensive equipment, more reliable and efficient, used for home networks. The next topic is network hardware and software. To build these networks, we need hardware and software. Let's look at some key devices. Key network hardware. This slide provides a great glossary of hardware. Repeater boosts a weak network signal to extend range, works at the physical layer. Hub, a basic connection point, it broadcasts data to every device on the network, causing traffic and collisions largely obstacle. Swiss, the intelligent version of a hub. It learns which devices are on which ports and sends data only the correct device, distinctly reducing collisions. The cornerstone of modern LANs. Router, the device that connects different networks together. It routes data between them, choosing the best path using IP addresses. If open performance NAT network address translation, allowing many devices to share one public IP address. Gateway, a broader stream for a device that connects networks using different protocols. It can translate between them. Bridge connects to similar network statements. NOU and NOT, essential for fiber internet. It converts the light signals from the fiber optic cable into electrical signals that your router can understand. The next topic is network protocols. First of all, learning objects. In this section, we learn define the theme network protocol, explain the purpose of common network protocols, and explain the use of common network protocols. First, network protocols. A network consists of two or more connected devices that communicate with each other using protocols, rules that define how device will communicate. Web protocols. HTTP, Hypertext Transfer Protocol, used by web browsers to request web pages. HTTPS, secure version of HTTP that data transfer to prevent interception. File Transfer Protocol, FTP, allows files to be uploaded to a server. It requires authentication and can also be used to download files, particularly large ones. Email protocols. POP, post office protocols, request new received emails from a server. SMTP, Simple Mail Transfer Protocol, sends emails to a server. IMAP, Internet Message Access Protocol, synchronize email clients with the server. The next is Transport Protocols, TCP, reliable protocol that slips data into packets and resends missing ones. UDP, faster but unreliable protocol that discards missing packets. Network and link protocols. IP, Internet protocols, packages, packets and adds destination IP addresses. ArthNet, family of protocols that links data packets and LAN hardware. Wi-Fi, wireless protocols that link data, packets, and hardware components. Office network design. A typical office network requires devices like routers, switches, TCS, servers, and copper cables Routers must be configured with IP addresses, typically using CLI. Cisco Network Simulation. Cisco Network Simulation is essential for CNA, CCNP exam preparation. It can be downloaded from www.netect.com and is used for designing, configuring, and virtual networks. DHCP configuration. DHCP works through four steps: discover, offer, request, acknowledgement. Configuration requires settings IP on router interface, creating DHCP pool with IP range and default gateway, specifying included IP addresses. Types of NAT. Static NAT, manual one-to-one mapping. Dynamic NAT, automatic one-to-one mapping from a pool of public IPs. NAT helps solves IPv4 excision by optimizing how IPs are used. The next, PAT, port address translation. Port address translation is the most common type of NAT. It doesn't just translate the IP address, it also uses unique port numbers to keep track of which private device each packet of data belongs to. This is how your home routers. Thank you. That brings us to the end of our comprehensive overview of computer networks. We have covered what they are, their types, how they communicate through the TCP and IP model, how they are physically arranged, and the hardware and the protocols that make it all possible. This foundation is key to understanding the digital world we live in. Thank you for your attention. Are there any questions?